Hello everyone, and this video I'm going to show you how to solve equation involving logarithmic and exponential. Okay, so for solving equation involving logarithmic one, we need some definition and some relation of logarithmic. The first and the most important definition is we say that the logarithm of x base b is a number like y if and only if you have b to the y is x is b to the y. So basically you can convert anything in logarithmic form to exponential and any exponential to the logarithmic one. Of course here we believe that x is positive together with b and x are positive, otherwise we cannot define exponential for b negative or logarithmic for x negative. This one is a must. And according to this definition, you can prove, and as I did in our class several times, and the logarithm of x, y, base any b, it's gonna be the logarithm of x base b plus logarithm of y base b. Of course, x, y, and also y is positive. X is from the beginning, we assume that it is positive, and b is positive. Now y is also positive. 2 logarithm of x over y base b is the same as saying logarithm of x base b minus logarithm of y base b. Number 3, logarithm of x to the power of r base b is equal to r logarithm of x base b. And number 4 is change of base, and it says that the logarithm of x base some c base c is the same as saying logarithm of x base b then divided by logarithm of c base b. Basically you can convert any base to any base. If you have a logarithm base of c, you can convert it by this formula to any base that you wish. Okay, now a combination of this four, you will see how we can solve these equations. For example, logarithm of x squared plus 4 minus 2 logarithm of x plus 1 base 2 is equal to 2. I want to solve this one. Basically, as you can see, I cannot directly use this second formula here because the second formula, the first one has coefficient 1, the second one must have coefficient minus 1 if I want to use it. But here I have minus 2, so basically I can move this 2 to the power, and by using number 3 first. So I can rewrite it like log x squared plus 4 base 2 minus this 2 goes and sit on top of x plus 1, and then we have this one. Okay, and then now I can use uh, I use number 2 here. I use number 2 and well, not number 2, number 3. I first use number 3 to put this 2 on top of this, and now I'm using number 2 to write it in form of fraction. So the logarithm of x plus 2, x2 plus 4 over x plus 1 to the power of 2 is equal to 2. And now here it is based on a star, which is the definition. Based on a star, you will get 2 to the power of 2, which is 4, must be equal to this one, okay? So the logarithm of anything base b is x must be b to the power of y, and I'm using exactly the same thing. So x plus 4 over x plus 1 to the power of 2 must be 2 to the power of 2, and then x squared plus 4 over x plus 1 to the power of 2. I just I just expand it. Or if you expand this one, then you will get x squared plus 4 over x plus 2x plus 1 is equal to 4. Therefore, you will get here, if you cross multiply, then you will get x squared plus 4 is the same as 4x squared plus 8x plus 4. And now you can see, you can eliminate this 4 from both sides, and then this x squared also will make this one 3x squared. And now if you put everything in one side, then you have 3x squared plus 8x is equal to 0, right? And therefore you will get x times 3x plus 8 equal to 0, and then you will get two answers here, x equals 0 and x equal minus 8 over 3. But if you look at your original, this is always the case, you have to double check. X equals 0 is good because it satisfies the equation, but not minus 8 over 3. This one is reject. We have to reject this one and accept this one. Therefore, the solution set will be only x equal to 0, right? And let's go through the second example. Next example. Again, the same story. Solve the following equation for x. I want to solve this one. Log 5, 2x plus 1 minus log base 5 x minus 1 is equal to 1. I want to solve this one. Now this one is ready to use because the coefficient here is 1, the coefficient over here is minus 1. Therefore, I can easily transform this one to log base 5 2x plus 1 over x minus 1 is equal to 1. That's it. And now use that definition of logarithm. Logarithm of something become 1, therefore b to the power of that one must be this. 2x plus 1 over x minus 1 must be 5 to the power of 1. And this will give you 2x plus 1 over x minus 1 is equal to 5. And then cross multiply, you will have a very simple linear equation. 5x minus 1. And then bring everything to one side. 5x minus 2x, it's gonna be 3x, and 3x 2x plus 1 x minus 1 is equal to 1. Everything is fine. 2x plus 1 over x minus 1 base 5 is 1. Then this. Okay, here I think it is 5. So if you cross multiply 5x minus 5, right? 2x plus 1 is equal this one, and then now you have minus 6. Am I right? Bring everything to one side is equal to 0. Therefore, you will get x is equal to 2. And if you plug in, then you will see that this is acceptable. So the solution set in that case is only that x equal to 2. Okay, the next example is logarithm of x minus 4 to the power of 2 plus 2 log 3x minus 5 is equal to 2. I want to solve this one. Well, here you have two options. You can bring these two on top and make the coefficient of logarithm exactly the same as 1 and then continue, or you can bring these two in front to make this coefficient and that coefficient exactly the same and then simplify. This may be a little bit easier. I will follow this one. So basically from here you will get a 2 logarithm of x minus 4 plus 2 logarithm of 3x minus 5 is equal to 2. Okay, now if you divide both sides by 2, you can easily get rid of this 2, and that 2, and then you will end up with logarithm of x minus 4 plus logarithm of 3x minus 5 is equal to 1. So you can imagine that I factor this 2 and then cancel with that 2 in the right side. Okay, or you divide both sides by 2, it is much easier. And from here to here, you divide both sides by 2. You get this one. And now logarithm of x plus uh, logarithm of y is the same as log xy, right? The logarithm of xy. Okay, so from here you can say that the logarithm of x minus 4 times 3x minus 5 will be equal to 1. And according to definition, 10, this one is 10, right? 10 to the power of 1 must be equal to this product. So x minus 4 times 3x minus 5 must be equal to 10. Now it is really easy, right? This one is not very difficult problem. It's a quadratic one. If you can, if you multiply, expand them, then you get 3x squared, this times this minus 5x, this times this minus 7x, this times that plus 20 is equal to 10. Now if you put everything together, then minus 5 and minus 7, it's going to be minus 12x, and minus 10 is equal to 0. I'm sorry, plus 10. This 10 goes here, and then you have this quadratic. And if you want to solve this quadratic, it is easy. Just find the delta and find the solution. Okay, I think x times 3x squared minus 5x minus 12, not minus 7. Minus 12x, and then plus 20 is equal to 10. Then you have 3x squared minus 17x minus plus 10 is equal to 0. Okay, then delta will be b squared minus 4ac. If you do so, it is 17 to the power of 2 minus 4ac, 120. Then if you do the calculation, you will get 169, which is 13 to the power of 2. So now x1 and x2 will be minus b, which is 17, plus minus a square root of 169, which is 13, then divided by 2a, which is 6. Okay, so you will get 17 and 13. It is 30 divided by 6, it is 5. So x1 is 5. And the other one is 17 minus 13. It's gonna be 4 over 6. 4 over 6 or 2 over 3. So now if you look at your original function, so 2 over 3 does not satisfy this guy here, therefore it must be rejected. So this one is reject, and this one is good one. If you look at the original one, always please be careful, look at the original equation, not the simplified version. Okay, and this one is the logarithmic form. Now let me give you some example on exponential form. So I would like to solve again for x this equation 4 times 2 to the power of 3x minus 1 is equal 16 to the power of x plus 1. So the basic idea here is if a to the power of x is equal a to the power of y, then you can claim that x is equal to y because a to the power of x are all these functions are one-to-one. Okay, and for this we need the base must be exactly the same, but here I have base 16, I have 4, I have 2, but it seems I can change all this base to base 2. Therefore 4 is 2 to the power of 2, then 2 to the power of 3x minus 1, and then 16 is 2 to the power of 4, then to the power of x plus 1. Okay, from here to here is basically easy. Just make all bases are the same, and then use some power rule in algebra. 2 to the power of 2, 2 to the power of a to the power of b times a to the power of c. It is a to the power of b plus c. Therefore, this gonna be 2 to the power of, add these two together, 2 plus 3x minus 1, so you will get 3x plus 1 is equal to, the next one is using 2 to the a to the power of b, then to the power of c, 2 to the power of 4, then to the power of x plus 1. So we have a to the power of bc. And now you can say that it is 2 to the power of 4x plus 4. 4 times x plus 1. And now use this, the rule here, or you can say that because 2 to the power of x is 1-to-1, therefore you have 3x plus 1 is equal to 4x plus 4, and then happily you can find x, this goes over there, this goes here, you will get 4x minus 3x, it is x, and then minus 4 plus 1 minus 3. So this is the solution for this equation, and there is no restriction here. So if we accept it, the solution set is accepted. Great. And now let me give you next example. It is x, sorry, 3 to the power of x times 81 to the power of 2x minus 1 is equal to 27 to the power of x minus 1. The same story, right? You can see, even though the base are not the same, but we can make them the same. So 3 to the power of x is fine. 81 is 3 to the power of 4, 3 to the power of 4, right? And then to the power of 2x minus 1 is equal, 27 is 3 to the power of 3. Okay, now what you need is carefully use the rule of products and something like 3 to the power of x, and here 3 to the power of 4, then to the power of 2x minus 1. Therefore, it is 3 to the power of 4 times 2x minus 1. If you are afraid sometimes that you may make mistake, so do not use shortcuts. Just do regular usage of the power rule, and then you will get this one, and then you have 3 to the power of 3 times x plus 1. Perfect. Now I believe it is 3 to the power of x. Let me simplify this one. It is 3 to the power of 8x minus 4 is equal to 3 to the power of 3x plus 3. Still, it's not good because these two are not the same they are not in single base, so but that's fine. I can a to the power of b, a to the power of c, it is a to the power of b plus c, so it is gonna be 3 to the power of x plus 8x minus 4, which is 9x minus 4, is equal to 3 to the power of 3x plus 3. That's perfect, right? Now you can claim that these two must be equal, and then 9x minus 4 is equal to 3x plus 3. And now it is easy to see that it is 6x, x bring x to the other side and 4 to the other side, and then x gonna be 7 over 6, and then happy. Find the solution. That's great. Okay, the last example that I would like to talk about is sometimes maybe it is impossible to make them in the same base, right? 3, 81, 27, that's fine. Here, 4, 2, 16, that's perfect. But sometimes it is not the case. For example, 9 to the power of x is equal to 5 to the power of 2x plus 1. How can I solve this kind of problem? That one is not really difficult too. As a matter of fact, the last example, which is this one, the technique that I'm using here, it can be applied to the previous last two questions, the last previous example, because this method is a unified method. So you can use it here, and also you can use it there, right? But for me, it was easier to make all the bases are the same. And the, the way that I'm going to solve this kind of equations is by taking logarithm of both sides. If x1 is equal to x2, then you can say that logarithm of x1 is the same as logarithm of x2 base of anything that you wish. This one is perfectly fine, and the other way also correct. One of the from left to right, it is because log is a function, and from right to left because it is a one-to-one function. We will see more about one-to-one function later, not now. Okay, now if you take logarithm from both sides, when you may say that logarithm of base what? Base anything. But I strongly recommend you to take base one of these two numbers, whatever you wish, because your calculation will be much easier and shorten. You will shorten your calculation if you take logarithm based on one of these two bases. Okay, it doesn't matter which one. I normally take the logarithm based on the one that has more complex power. For example, 5 here. It is not a mandatory, it is just a recommendation. So take log base 5 of both sides. This is the technique. So logarithm of base 5, 9 to the power of x, is equal to logarithm of 5 base 5 of 5 to the power of 2x plus 1. That's perfect. And now from here, you will get x can go, x from here can sit in front, 2x plus 1 also can sit in front, and then you will have x logarithm of 9 base 5, okay, is equal to 2x plus 1 logarithm of 5 base 5. Okay, now you know this one is 1. This is the reason that I said it is the best idea to take the logarithm based on one of these bases. If you take the logarithm base 9, then this guy will be 1. here. So always you end up with one of them is 1. But if you take logarithm based on, for example, 10, then you have logarithm 9 base 10 here, and you have logarithm of 5 base 10. Both sides you have logarithm. That's absolutely fine. Doesn't matter. But it is easier for us now to work with base 5. And then you have x logarithm of 9, 5 base 5 is equal to 2x plus 1. That's it. That's almost the end of the story. Because this one is a number, right? This one is a number like 4, 5, 6, whatever you want. This one is a number, but unfortunately, it is not, I cannot simplify this one. I can actually write it like 2 logarithm of 3 base 5. I can do that. I can do that. But it is not necessary. I can do it at the end. So what is the solution? Bring all x in one side, okay, and then you will get, let's say, logarithm of 9 base 5 times x minus 2x is equal to 1, right? And now take x out, so logarithm of 9 base 5 minus 2 times x is equal to 1. And therefore you can find x. X is equal to 1 over logarithm of 9 base 5 minus 2. This is a number. It's a perfect number, but it is not like 1, 2, 5 that is integer and you know it, but it is a number. Over 9 is 3 to the power of 2. You can write it like 2 logarithm of 3 base 5 minus 2. And now you can even do more simpler, 1 over 2 logarithm of 3 base 5 minus 1. Even still, if you wish, this is just for, more practice on your ability. And still you can do something. That's perfectly fine if you leave it like this. But I will go through some more simplification. It is 2 logarithm of 3 base 5 minus, instead of 1, I can say logarithm of 5 base 5. Okay? And now I can say it is 1 over 2 logarithm of 3 over 5. 3 over 5 base 5. That is absolutely fine. You can write it like this. This one is just a little bit more compact than this one. But you can use your calculator to check both of them equivalent to the same number. Okay, so this is all I want to mention about how to solve equation involving exponential and involving logarithmic functions. Till next time, have a good day. Bye-bye.